all get some kind of comment about recording.
Yeah, you either get to leave or be okay with it recording.
I'm sorry?
You either get to leave or you get to accept that it's being recorded.
I don't know. I'll get sort of figure that out, I guess. Anyway, so we're now being recorded, and if I get the opportunity, and I have no idea where I'm going to find the time, because this whole process takes a lot more time than normal. By the way, am I looking at you right now? Okay, because when I look to see myself, I'm not looking at myself in another camera. And all I can see right now is Trent. So anyway, the setup, as I said, at the university will be when you're there, you're supposed to have a mask on during the class. I'm going to have a face shield up in front, which allows you to see my lips moving and smiling and looking at you harshly and all that kind of stuff, as opposed to just being a bandit like you guys will be. So all I will be able to tell is whether you're asleep or not, probably. But we'll work all that out. I think all this we'll get used to. And so far, I might look, as everybody who is here, let's see, Creed is with us, I think. Yes, Remington, I haven't received from you yet what days you'd like to come. Also, Escabel, I haven't received anything on what day you like to come. I have somebody else coming in here I need to admit. So Philip is now admitted, I think. So Philip can hear me, that's good. But Escabel, I need to find out Monday, Wednesday, or Wednesday, Friday, or Monday, Friday. Mr. Jackson, I don't know yet. And Mike and Thompson, I don't have anything back from you guys as to what time you want or what days you want to meet. Now, at the moment, we have 10 people on Wednesday, 8 people on Monday, and 4 people on Friday. Once we get 15 on Wednesday, we can't have anybody else join up on Wednesday. So if you guys don't get your requests in and you happen to, and Wednesday happens to fill up, then you're going to have to take Monday and Friday. Right now we're okay, but Wednesday is the most requested time. So everybody so far has got their times. If you sent me an email before 9 this morning, I've already put you in, and I think we're going to have to keep that for a while. We might be able to get into a different phase so we can go up to 30 people. If that's ever possible, then we'll be able to have the whole class in class. I know that Manish, you said you could go either Monday, Wednesday, or Monday, Friday. You can decide that if you want, because right now you could do either one. Later, if more people want Wednesday, we may shift you to Friday.
Yep,
but that okay. Will only be with your permission since you got in early.
Right. Yeah, that will be fine.
Are you in Wichita?
Yes, sir.
How did you get here?
United Airlines was operating from India to US special flights. So I came back on 6th.
Did you have to quarantine?
Yeah, like it's not strict, but they recommended us to stay inside our apartments for 14 days.
But you're done with that now, probably, or just about.
Yes, sir.
Okay, just curious, because I didn't know when I sent out your email, which I did about 4 in the afternoon, I didn't know if you'd get it or not. Jeremy wants to come in. Anyway, thank you. Jeremy is now with us. It's being recorded, Jeremy, so once we get the tape recordings done, you can hear whatever I said before if you want to. I started to tell you guys that if I get the chance, and I don't know, I will try to edit some of the crap out of the video that we might get into sometime, or if there's anything that like wasting time like now, like right now, I might be able to just edit that out. I don't know. I may not have that time to do because editing takes time to do well and things like that. But I'll be trying to present you with a video version that's not too bad, hopefully not worse than what we have to suffer through right now. Anyway, don't have anybody else coming in right now, and I now have how many people? 1, 2, 3, 4, 5, 6. Pretty good, I guess. At someplace, 20 participants, and 3 of them's me, so 17 out of 20 here. Okay, so let's start talking about the class. First, I've already said to everybody, but you will need to have a mask once we start the in-person sessions, which I hope we can start. I think for the first few days we can do this until, like, for example, there's 3 or 4 people who may not come today and they won't know what to do. So I think we need to, Monday, Wednesday, Friday this week, we'll probably keep doing this. And then we'll sort of see by Friday whether we can start going to class or not, the in-class time. But I hope you don't disagree with that. As I say, what we don't want people, we've already getting calls in the office of people who don't know where they should go. I hope none of you have had the call. I may as well just tell you, one thing you may see is I'm wearing long sleeves. And the reason I'm wearing long sleeves is because a couple of weeks ago I made a mistake and cleaned some brush out of my yard. And for the first time in like 60 years, I got poison ivy all over. So my arms have been suffering for the last few days. And I thought I wouldn't want to show you the ugliness. My face is bad enough. And so that's another reason why I don't want to go to class right now in class, because it's hot outside and I don't like to walk around outside with the long sleeve shirts, but it's more hygienic and fortunately I'm on the mend in the sense that the itching is pretty much gone. I don't scratch, but still it's bad stuff. Don't get poison ivy or poison oak or poison sumac, whatever it was that got me. Normally I don't have that happen, but I did this time. So, and don't believe whatever the doctors tell you, because I've learned that their advice doesn't necessarily mean anything. They told me certain things would not spread and they did anyway. So, okay. So I've already covered that. We're going to start in chapter 12. Now, chapter 12, for those of you who were in my class last spring, we did a little bit of chapter 12 or most of chapter 12 at the beginning. Cameron, I have coming in here, just a minute. So Cameron is now in, I hope. So again, if anybody sees somebody waiting, or I don't know if you can see it, can you see people waiting? Or do you have to be emailed or chat? I don't know how that works. I can see people are waiting. I don't know if you guys can or not. Okay. Well, anyway, if somebody asks to come in by email or something to you guys, or chat or do whatever, you might remind me. And also, again, remind me to record all the time. Okay, chapter 12 should have been covered by the last class you took. Now, is anybody not familiar with the book? Did all of you take this class last time or sometime when we use the current textbook? Anybody not use the current textbook before?
That would be me.
Okay. Well, you'll need, if you haven't done this material in chapter 12, it'll be new for you. But it's okay. I'm going to try to do 2 things simultaneously. One is to review chapter 12, which I think when you look into it, you will find what's in the book pretty easy compared to some of the stuff I'm going to throw at you. Okay. So I think what you do is go back and forth. If you read my notes I gave you on Blackboard that I put on Blackboard yesterday, and I'll show you that in a minute. After a couple of pages of introduction, I tell you to go read sections 1 and 2 of chapter 12. For those of you who've seen the book before, you've already done those sections. About half of you, or maybe a little more, had my class last semester. And if there's only one person who hasn't had that book, this book, I can help you as well. But the rest of people would have seen chapter 12 anyway. So assuming most of you have seen chapter 12, and maybe you've done some of the WebAssign exercises also, I'm hoping we can do a light touch of that and still review it. And by the way, the reason my voice is the way it is is because the medicine I'm taking affects my voice. And also hopefully cures the poison ivy, but it affects the voice because it dries me up. And so it's an interesting side effect. Okay, I think what I'll do, but instead of talking about the chapter for this second, is do something here that we should talk about. I have to find it. There, okay. Okay, is what's on the screen now is a syllabus, I hope? Yeah, okay. Now, this syllabus is, it was the one that was, well, it's a revised one, the one I sent you out last week, or a few days ago. But I had to revise it for two reasons. One, I left out Thanksgiving break of the first one. And so if you looked at this a few days ago, it basically said you're going to be in class Monday and Tuesday of Thanksgiving week. And I just missed that. Actually, we are dropping fall break and putting those 2 days into Thanksgiving. So I presume you know that already. Anyway, I had to revise the syllabus so that it reflected that. So this syllabus that you see right now, if I go down to that sort of thing, you'll see, I hope on the screen now, that there now is a Thanksgiving break here. And so the last in-person class will be on 11/20. And from then on, another couple of weeks, we're going to be doing what we're doing now, except that I'm not supposed to make you do anything during the break. So we're allowed to fill you up with stuff before the break, things you'd never get done before the break, but we're not supposed to talk to you. We're not supposed to do anything. I don't know why, it's silly stuff. But don't give them anything to do on break. Okay. So anyway, then we're going to have a week after, 4 days after the break to finish some stuff up. So now, as far as the syllabus is concerned, the one that you now have is more accessible, meaning for blind students and deaf students and stuff. This is the one I originally had. It's prettier, but it's not as accessible, so I had to replace it. Anyway, I don't need to talk about honesty because I'm sure you're all honest. The course description is in the learning outcomes and stuff. That's all good stuff you can read. The email, has anybody had trouble getting on WebAssign? If so, you should email me or something. We can try to work with that. I've now got, I think, 8 of you on WebAssign that's signed up. I know about. And attendance is very important. I want you to be here every day, either online or in class, if you can do it. If you have to be gone at some time, I don't know how we're going to find out whether you watch the video or not, but try to bear with me. We need to have, because I want to give you some points for attendance, but you know, if I don't know where you are or when, it's harder to do. So now grading is going to be 4 tests and a final. We can talk more about that later. The rest of the stuff you've seen already before with other people and stuff. We are going to do stuff on Blackboard. I'll be putting notes on there all the time on Blackboard, especially when we're doing things like this, because I think I think this kind of format, what you're reading, is good because I can point out stuff and you can't just sleep as well without looking or something. Anyway, attendance important. 1 extra credit week, because we're all going to have 4 tests instead of 6. It's only going to be 15 possible points to add to your grade to help you grade-wise. And so you can read about that. Homework, I may award points for homework because I really want you to do the WebAssign. And so if that extra carrot helps you, we might do that. I don't want you to be late on homework. Is very important because you guys have learned how it's like when you do no homework. This temporary schedule here, I don't really know because we're going to be trying to do chapter 12 and some notes that I'm going to hand you. The notes themselves are quite a handful. And if we try to do them both at once, I don't know how long this is going to take. We're supposed to start in chapter 13, but my experience is when we do that, some of you didn't learn the vector stuff in chapter 12 like you should have. And so I want to review first. How long it'll take to review, I don't know. So this schedule is only tentative. And also, none of the schedule acts like we are doing this online. It all acts like we're doing it in class because I really didn't know how this semester is going to go. if we have flare-ups on campus and they change the rules on us, then anything we say in the syllabus will change. So I'm hoping you understand this is a syllabus that acts like we are having a regular class. We'll have to handle the things that are online as we meet them. So I will try to be as helpful to you as I can be on this whole thing. I hope you're also as helpful with me as you can be with this whole thing, because it's a mess. And my biggest problem is not you guys. My biggest problem is the several people we hired who have never taught math before who have to do this sort of thing. And I'm not sure the instruction that you're going to get around the campus is as good as you'd like. But I hope that by what I'm trying to do, which is to set up all this live stuff, I'm hoping you'll be happy with what we're getting or what you're getting from me. So we'll see. Anyway, anything, the last part of the syllabus is how you get on WebAssign. That's new because for Calc 3, because I've never done Calc 3 and WebAssign before. Oh, a little secret that I've been teaching Calc 3 honors for some semesters. So I have notes that are geared to the other text that we used up till this fall. I have nothing made up for this fall all the time. So what I'm doing is looking at those old lectures and looking at the new part of the book here to try to put out notes, but it's a long process. So I'll be putting out notes on everything, but sometimes you might find a page 20 or something, which really should be page 893, because maybe I didn't get all the pages changed when I want to present the same material. So I hope you'll bear with me on that. And if you find out that there's something like, why are we in page 20? Because we're in Calc 3 and page 20 is Calc 1. You might remind me like, hey, you didn't get that page changed. But otherwise, some of the material that I want to present you is generic. It has nothing to do with any given textbook. Professors in universities don't go through books. What we do is teach our course and use a book as a supplement. If you're used to high school teachers usually go right through the book, but college professors, the general, well, college is a better than thou subject in math, you know. Professors in math think they know everything. And so they think anybody that wrote a textbook doesn't know as much. And that's just the way we all are. So, and by the way, that's a first attempt this semester that I'm making at humor a little bit. Those of you who don't know me know that I'm likely to go off on some tangent and tell you about something totally unrelated to class, supposedly. Except if you really look into it, you'll find out it's always related. You just weren't clever enough to see the connection. But I'm hoping this class is fun, not a torture. I have a lot of stuff. I've been still writing my book. I'm on page 2300 now of the book that I'm writing. And I learned a lot of stuff this summer that I want to add to the class. So I'm hoping this will be a really fulfilling time. And I don't see anybody. I don't have my chat here. Let's see, participants 21. And nobody else is showing up. Okay. So so that's the syllabus. Any questions about that? You can read it. We can have questions on Wednesday if you want, if you have some questions there. I might try to switch over to, let's see if I can quit this share, stop, and go over to another share, maybe. This will get better as I get back into it. I presume you now see WebAssign. Now, do you guys see this kind of screen or do you see something else? Because let me show you the something else. I have up here on my screen, I'll have to move some of your pictures. My screen is Open Student View. So I'm trying now to open student, which I never look at. This is what is called a student view. Is this what you're used to seeing?
Yes, that is what we see.
Okay. So what you'll see here is that I've put 4 sections on chapter 12 that supposedly everybody who takes that took 243 did last semester. Now, again, if you didn't have the same book, you might not have. But so what I did is I went into 12.1 and 12.2. And what I'm used to doing is what a textbook does, which is to put 80 problems in the book, but only assign a few of them. That's what most people do. Well, I want you to do more than the minimums. What you need to do with exercises is do as much as you need to understand. And if I give you 5 problems, but you don't understand yet, you need to do more. So any assignment is always a minimum. And so what I did though in 1 and 2 is I went in and took the 80 problems or whatever and cut them down, because it is supposed to be review. So you don't need to do 10 adding 2 vectors together. So I cut that down to maybe 1 adding 2 vectors together to see how to do it. So I cut the first 2 of them down. 3 and 4, I left with as many problems as the book allows me to put in. So when you look at 3 and 4, they're more do what you need to do. Section 3 is about dot products. Section 4 is about cross products. Okay. Now, the notes we're going to go to in a few minutes do dot products, but don't yet do cross products. So for the next couple of days, we're going to be doing the notes. What you guys need to be doing is supplementing that with looking at chapter 12. Okay. So anyway, the chapter 12, 1 and 2 are due toward the end of this week, or like Wednesday and Thursday. So I want you to get in there and do them. I believe 3 and 4 aren't due till next week. Okay. And so we can talk more about that later, but I thought I ought to bring that up. Okay. Now I want to go to something else, which hopefully will be, let's see, sentence is this. Yeah, hopefully now something will come up that is what I put on WebAssign. And I have to get it on my screen here so I can do it. Okay, so what this does is, and let me look on a sheet here and make sure I'm not seeing anything else. Oh, let me ask you about the WebAssign problems. Is it okay if I leave them all up and maybe either say do a certain number of points, or if I maybe list some problems to do? Is that acceptable? Or do you want me to go in and cut them down all the time?
I think just saying a certain number of points is good.
Assign assignments. Okay. So I'll assign a number of points and then you can choose which ones to do the points. Okay, good. Okay, let's see. I think I'll try to be putting notes up on Blackboard all the time. Everybody found this, all you guys found the session. Oh, wait a minute. No, from Cameron, everybody. Okay, you were doing some chatting. Okay. Yeah, I think we're ready to do things. As I said, I would appreciate from Creed and Escobel and Jackson and Holston and Thompson, let's see, and Mink, your choices for Monday, Wednesday. As I said to people that came in earlier, right now there's 8 people coming Monday to class, 10 people coming Wednesday, and 4 people coming Friday. We can go 15 each. And as soon as I get the Wednesday up to 15, then anybody left over is going to have to do a Monday, Friday, things like that. So please get your requests in. And the earlier you get the request in, the more likely you can. And Cameron says he just sent an email. Okay. So he will be the next person. So he has his choice of all 3 spots right now because there's still room. Anyway, I'm hoping to allow you that freedom so that you can minimize the problems with all these online courses and in-class courses. Okay, now this stuff at the beginning, the first page and a half, is just kind of telling you welcome and what we're going to be doing and so forth. And it gets down to the middle of the second page, and I say at this point you ought to read or reread 12.1 and 12.2. Now, I'm going to switch over here off of this and show you something about that, because after you read 12.1 and 12.2, then I do some critical review of it, and that's in here. And so rather than show you that right now, I'm going to hopefully get off this share and go to a different share. And as I say, I'll get used to doing this better. Where is my other thing? Here. Okay. Presumably now you will see a book. Okay, this is 12.1, as you can read. And what the author does is he puts up a coordinate system and right away starts talking about, in order to represent points in space, we choose a fixed point and we do 3 directed lines. Now, the interesting part about that, the critical part that I have about that is that I asked the people when we did this in 243 last spring, what is the equation of a line in 3 dimensions? Nobody knew. All right. And for you guys who haven't been with me before, tell me what the equation, if you want to unmute and tell me what the equation of a line in 3 dimensions is. If you've never read this material before, I don't think you know. Now, even if you do know, what's a straight line in 10 dimensions or 1,000 dimensions? The point is you've never thought about it before. So how is it that we can talk about directed lines and use this picture if we don't know what lines look like? Now, of course, we do know what lines look like in 3 dimensions, but what's a dimension? Maybe can you define a dimension? When people talk about we live in the 4th dimension or something, or whatever, the 4 dimension, what are they talking about? So my problem with the book, and every calculus book is like this, they start off assuming that because you know about straight lines in 2 dimensions, that you can just, because we live in 3 dimensions, immediately understand what to do, and so forth. And we talk about right-handed systems, and it gets into all kinds of good stuff real quick. And what you'll see all over the page is, this looks like the what's in our arena for basketball, but basically he puts up all kinds of pictures and so forth with how you plot points. And I think you know that really. To go to a point with 3 components, you have an X component and a Y and Z and so on. Anyway, he sets up a coordinate system, but that assumes we know what straight lines are. And when do we do straight lines in chapter 12? Section 5. So we have 4 sections of chapter 12 before we learn what a line is. So it kind of bothers me when you act like you know what a line is before we define one. Okay? So when we do my notes, I will define lines first, and we don't have any pictures first. Okay? Anyway, the second thing we're going to be talking about, which again you need to be familiar with, is pictures of things, surfaces of things. And the first 2 surfaces he shows you are what equations fit with pictures, certain pictures of vertical planes and horizontal planes. And that's one page. And then on the next page, he brings in components. Sorry, not on the next page. On the next page, he brings in some other pictures of things that you can view in 3 dimensions, and you can look at all that sort of stuff. Sooner or later, he gets to components. Once he gets to vectors, he combines vectors in 12.2. And if you look into this, he's declaring a vector to be a directed line segment. So he's totally relying on geometry. He's not relying on analytical mathematics. He's not relying on anything but you thinking you know what arrows look like. The trouble is, what do arrows look like in 7 dimensions? That's a good question. Anyway, he shows you how to add vectors if they are directed line segments, like what you see here. This is, if you have 2 points, A and C in a plane, to go from A to C, you draw an arrow. And you can get there if you first have A to B and B to C. I know you guys know all that. This is what physicists want us to do for forces. So we want to create a mathematical system that gives a physicist these kind of pictures. The point is, once mathematicians started studying vectors, we learned that they're much more useful than just arrows. But for the author, he defines addition to be adding arrows, okay? And he defines scalar multiplication on the next page as multiplying an arrow to make it longer or shorter. He just tells you it's a longer thing. Again, it's a geometric thing. what he does to introduce vectors is 100% geometric. The trouble is that's not what calculus is. Calculus is not 100% geometric. Now, so on the next page, he talks about components. Components is where we try to bring in section 1, where we talked about ordered pairs and ordered triples. And so he shows you here how to place a point, which is for him an arrow, a vector, in 2-space or 3-space, as we call it. All of this without definition. And then he tells you to add to vectors, to subtract. He says subtract the components. Now, what you'll notice here is he hasn't told you yet how to add them. Okay, so he's going to tell us to add them, you add the components. But it's kind of strange that we have subtraction before we have addition. That never is the case. Now, the reason he does subtraction before addition is because he needs to compare different directed line segments with each other. And he wants to say that a vector can be represented in several ways. Now, anyway, I want you to read these 2 sections and digest what he's trying to tell you, because I'm going to rip all that up in a little while. Okay? But I want you to see the way it's taught, and I'm hoping you'll appreciate what I'm going to give you is the real stuff, what mathematicians do, not what people who think they know about math do. Okay? And so I want to get off of this now. And by the way, the questions that are in the book, if you don't have WebAssign yet and you have a text, most of them are almost the same as the ones that I left in sections 1 and 2 in WebAssign. And so you can do the ones in the book if you don't have WebAssign yet. I just want you to review. But for now, I want to stop this screen and go back to those notes, which I'm hoping you will not think are terrible after you get to know them. So, okay, so presume at this point that you have read sections 1 and 2. Okay, now, so I bring up some of the stuff I've just talked about right here about, like, what's the equation of a straight line and all. You can read through this. All this is me, because when I read the book, I think, this doesn't do enough for me. This doesn't really answer my question. And the biggest question is, okay, is right here. If I take 1, 2, 3, now you can think of that as 1, 2, 3. That was a movie in 1950, for example, about the wall in East Germany and the problems in Berlin with James Cagney. Interesting movie, but who cares? That's my tangent, you see, right away. My mind goes to these weird things because I don't care about this class. And I'll have to edit that out of the recording. Anyway, nobody's laughing, so I'm sorry, it wasn't funny. If you have 1, 2, 3, what I want you to think about for a minute is just 1, 2, 3. Don't picture that on the screen. And 2 minus 4, 7. Just picture 3 numbers. Okay, like a I don't know, to unlock your door or something with a key pattern with numbers, like if you have a code. Well, we can certainly take 1, 2, 3 and 2, 4, 7 and add the first ones together, the second ones together, and the third ones together. And if we do that, and if I didn't do it wrong, we get 3 minus 2, 10. Okay, now, completely separate from that, we can place 1, 2, 3 in a coordinate system like you will read in section 1, and we can place 2 minus 4, 7 in a coordinate system. Now, these are harder to do on a piece of paper because you're trying to make the paper look 3-dimensional and it never will, okay? So it's harder to do the picture, but you can conceive, if you look at the corner of a room like you're in, you can make up a 3-dimensional system, like you guys, or some of you have seen me do in class, where I walk around to show you where a point is out in the system. But as soon as you get to -4, you're going the wrong way and you're in the next room, technically. So anyway, but so we could take those 2 arrows and try to fit them together, and we will get a third arrow, which is called the resultant of the first two. That's great. So we can do either one of those two things. Now, what I'd like somebody to prove to me is that we end up in the same place. How do you know that adding numbers up this way will get you to the same place that the arrows get you to? The book totally omits thinking about that at all or presenting it. And to me, that's the whole deal. In 4 dimensions, how do we know we get a 4-dimensional arrow which we can't see that does the right thing? Or in an infinite number of dimensions called a Hilbert space. Anyway, there's all kinds of stuff that we do in math that goes way beyond arrows. And so what we got to do is learn what are the rules involving arrows and what do they give us? Now, if they happen to give us what the physicists want to have happen with resultant forces, which they do, by the way, but we need to prove that they do. And the book doesn't do that. The book just says, here's the way it is, do it 2 different ways, it's the same way. They don't justify it, okay? So anyway, I just wanted to say that's one of my reasons why we're going to be doing more. So now, so I had this before to reiterate, in the text pages you've read, points in the plane of space are completely identified with ordered pairs and ordered triples. When you consider an ordered pair, you're programmed to instantly consider a point in the plane or space, which have coordinate system imposed on them, and conversely. In a similar way, when you hear the word vector, you may automatically envision a picture of an arrow, and you may not realize that vectors may be defined in a way that has nothing to do with arrows. It turns out much insight and understanding can be gained by considering these concepts separately and not trying to make automatic connections. So now, of course, when we think about vectors, the first thing that comes to mind is arrows, but sometimes that's the wrong thing to think about. Now, some little bit of nomenclature. I'm going to use this script N for natural numbers. That's 1, 2, 3, 4. I'll use W for whole numbers. If I want to add, if I want to do something less, this is an open interval. It includes, but this could mean the real numbers between 1 and n. When I want to talk about just the numbers 1, 2, 3, I put a little n at the subscript here. So you'll see that in your notes. I don't know if I can I blow that up for you? Or that doesn't blow that, does that blow that up for you? It blows it up on my screen. I don't know if it blows it up on your screen. Doesn't, okay. Anyway, let's see. Can I make it bigger? I see people looking at the thing, so see if I can make it bigger. I don't know here. Can't get to it. What I did is I made my pointer large and now I can't get to stuff. Is that bigger?
Yes.
Just a second. As I say, I have a huge pointer now, so let's see if that's better. Sorry about this. We'll get used to these things. That's easier to see now? It's easier for me to see. Okay.
Yes.
So if I just want to do 1, 2, 3, 4 and stop it, or all the numbers this is 1 to n, but it means natural numbers. If I just say 1 to n with no subscript, that means 1, 1.5, and square root of 7 and everything else. W is you add 0 to natural numbers to get whole numbers. Integers is z. It's z because we use a German word for Zahl to say number, because n, it means something else, namely natural numbers. For Q, I think Q is picked mainly because it's next to R for real numbers. But anyway, we have rational numbers. Universal quantifier. I'll be using this for all, for every, for each, for any, and so forth. And as extension. Mathematics is completely done with quantifiers of one of these 2 types. We'll get more into that as you guys who are new will learn that about from me, and we'll talk more about it. Generally, anytime you don't understand something symbolic, you should be asking me, because sometimes I forget that I haven't told you. Okay, now here's where the part begins, and we've only got 10 minutes to talk about a little bit, but I'm hoping this is readable, but it is very abstract. Now, but the first part of it is pretty easy, presuming you know about Cartesian products. That we write it this way, it just means pairs, where you take the first thing out of the first set, the second thing out of the second set. So if we were picturing things on a plane, that would be the whole plane. If we were picturing 3 dimensions, this would be the floor. Except this is not really in 3 dimensions because it would then have 3 coordinates. So if I'm picturing the floor in 3 dimensions, I'd have a triple, and the third part would be 0. So we jump back and forth sometimes. We sort of think of this sometimes as being the floor, because sometimes we have functions that go from the floor up into the space, and we make surfaces from that. So a function is going to go maybe from 2 dimensions to 1, but when we put the graph together, it's a triple. And we get used to sort of going back and forth with that. Anyway, all functions involve ordered pairs. But for example, a function in 3 dimensions is going to have a pair as the first 2 things and a single thing for the third. So it's going to look like x, y in parentheses, comma, z. We'll see more of that. Anyway, the first things you use are called the domain. The second things you use are called the range. You guys know some of this. What is new to some of you may be, what's a relation? The relation is a very general term meaning a set of ordered pairs. For example, we could say parents and children. Parents are the set and children are a set. If we pair a parent with a child, that's a relation. If we give some description of how we're going to parent, like it's your child or something, and then that would, if you're in a room full of people, adults and children, that would pair up certain people. Maybe not physically, but at least everybody would know, like hold your hand up if you're the parent of some child, and hold your hand up if you're the child. You make pairs that way, okay? Well, so I have some things here. X squared plus y squared is 1. That's a bunch of points. It's actually a circle, but we can consider that a relation. It's a set of pairs. We can consider the things inside the circle as a set of pairs, and including the thing. We can think of a half plane as a set of pairs. We can think of the things being triangles. When 2 triangles are congruent, we pair them up, okay? And we use a different symbol for that. We can think of parents, as I said. So first, relations are very general. And we can say, and we talked about this last semester, you can make a relationship to be in love with, for example. This is a complicated relationship, as some of you, as you grow up, are going to find out about. Now, we judge relationships in math by 3 criteria. One is whether or not everybody in the relation is related to themselves. The second is whether, if I'm related to you, are you related to me? And third, if I'm related to you and you're related to a third person, am I related to the third person? And I sometimes make jokes about people in our class. If we talk about to be in love with, is it true that everyone in our class is in love with themselves? Now, that's going to differ by different classes. All right, there may be some people who hate themselves, and therefore, if everybody in the class is related to themselves by that relationship to be in love with themselves, then that relationship is reflexive. If somebody isn't, then it's not reflexive. Okay, anybody that's not kills the whole thing. If I'm in love with you, is it required that you be in love with me? Thankfully not. Okay, so to be in love with is not symmetric. It doesn't return. As soon as I'm in love with you does not mean that you have that relationship to me. What you do sometimes is go to prison because you believe in such things. The third thing says, if I'm in love with you and you're in love with the third person in the class, am I in love with the third person in the class? We would probably say definitely not. So love is complicated because it doesn't have any of these 3 traits. On the other hand, what about congruent triangles? Is a triangle congruent to itself? That means does it have the same size and shape? And the answer is yes. If I have 2 triangles and one has the same shape as the second one, does the second one have the same shape as the first? And the answer is yes. And if I have 3 triangles and the first 2 are congruent and the second and third are congruent, is the first and third congruent? And obviously, again, yes. So there is a relationship that has all three. And that's called an equivalence relation. Equivalence relation takes all the triangles and separates them into groups of ones that are congruent with each other. Okay? Rational numbers actually are equivalence classes of all the fractions, like 1/2, 2/4, 3/6, -4 over -8, and so on, are all part of one equivalence class. I haven't told you what the relation is, but it turns out to be an equivalence class. We talk about that later in these notes. So what we do is we talk in general about what a relation is. By the way, the inverse of a relation, we'll later talk about inverse functions. That just means turn all the pairs around. Simple enough, turn all the pairs around. A function is a certain kind of relation. And I'm beginning to run out. I mean, I only got 16 minutes, I only got 4 minutes to go here. But I define functions. So this stuff you've seen before, but maybe not in this way. Okay? So here's an equivalence relation. Like the hardest little thing to understand here is the notation. But all this thing says here is an equivalence relation has those three traits. What this symbolism means here is all the things that have the trait that A has. Okay? This says that the trait that X has is shared by the trait that all the things that share X is Y. This is symmetry, and so on. Anyway, this equivalence relations have the idea that everybody is in some class and nobody's in both two classes, okay? So this is the hardest thing of this particular part, but it just starts the hard stuff. Next thing is to mathematically define what binary operations are. Now, what binary operations do, and you'd use them all the time, if I want to add numbers together, I take two numbers, that's a pair, and I have a process for putting them together and getting a third number. When you always get back in the same system, it's called closed. Like if I take two positive integers and add them, I will always get a positive integer. But if I take a positive and a negative, I may not always get a positive. Anyway, so we define a binary operation. It's a way of combining things, and I do it in a way you've probably never seen before, but a little bit later in the notes, I do what you have seen before. Commutative operation is A times B is B times A. Associative means how you group them. An identity element is something that leaves things alone, and so on. So what I'm doing is some very abstract stuff. For example, when we get into some matrices, the identity matrix will be a certain matrix. And we'll be able to add matrices, totally different than adding numbers. You guys add functions. We multiply functions. They satisfy these same rules. Some of them, for example, matrices, when you multiply, do not commute. You can't, we'll learn when you multiply two matrices together one way, it doesn't necessarily mean you can multiply them together another way. That's all in the future. So what I'm trying to put down here is the underlying keys to all the math we're going to be doing. And you will get used to this and you'll get familiar. I want you to be reading these notes as we go through the semester, because you won't understand it all now. You won't like it. You wonder when we're going to get back to real math. The point is you'll find out that you never have been yet in real math. And so some of you will love it because you'll find out what it's like. Others of you will hate it because it's not like what you thought it was. Some people will change from being engineering majors to math majors, and some people will flee math like a plague. Anyway, but hopefully I want you to be able to judge it. So what I do here is start giving you examples of different kinds of operations and what the properties are. And what we're really doing is reviewing the rules of arithmetic here. So if you forget all the abstract stuff, we're reviewing how we classify stuff and what you can do with rules of arithmetic. And like you've seen this before, A times B plus C is AB plus AC and so on, okay? So I'm actually reviewing the properties of arithmetic here, but I'm doing it in a very abstract way. And I'm naming things. Like integers are a kind of thing called integral domains. Real numbers are called a field. And when we want to talk about complex numbers, that's also a field. As soon as I say it's a field, that will tell you what its rules are. And I see it's 19 after, so I do have a class in 10 minutes, 11 minutes. And so anyway, I put together some notes here at the beginning that have nothing to do with vectors and stuff. That's section 12.1. Now, When you get to 23, I try to do the same kind of job that the author does without defining things properly. But I do it differently in the sense that I say, okay, how can we put together things if I just assume a vector is something that has a length and a direction without trying to figure out what that is? No components now, just length and direction. How can I do stuff? And so I go through several pages of trying to add and multiply vectors and stuff and subtract up to page 20, up to page 29. And what that is another feeble attempt at trying to make it work. And you'll see how much trouble I have trying to get things to work with all this stuff here. No, so the semester really starts with page 30. Okay, the first 19 pages are going to be used throughout the semester. 20 to 29 are just going to be as an example you probably won't like. And then from here on, this is where we really start the good stuff. So here's where I define a vector space, which brings up what vectors are. A little bit later, we talk about line segments, what lines are, and so on. What perpendicular is, dot products, all this kind of stuff. So these notes that you have go through the first 3 sections of chapter 12, but not in the same way. So for the next day or two, we're going to be spending time on these notes. So please read the notes. When you get tired of the notes, go and do a few exercises in chapter 12. Okay? So please, on Wednesday, let's have a talk about how you're doing. Could you not read page 1? Could you read page first 20? How did it work? Okay? And I'm going to have to leave you guys because I do have another class starting. Let me ask anybody, I think you can all you can unmute yourselves, I believe. Anybody got anything to say? How are you doing? Are you happy to be back? You're sad? You're mad? Am I different?
So happy to be back.
Am I too old? You guys know that once we get to class, you can perform a perfect murder, you know, because you can be asked, you know, you can have the disease and nobody knows and breathe on me. And I'm 79 years old. I will die. No one will ever know. So for that reason, if you get close to me, I will be punching you.
First day and we're already getting threatened again.
Because I may as well do that before I die. That'll at least give me some pleasure in my misery. Anyway, anybody got anything to say?
How different are these notes from what you gave us last semester with the similar topics?
Yeah, they're a little different, yes.
Okay.
A lot of it's the same, but it's different, yes.
Okay.
Anybody else?
It's just good to be back.
Okay, I need to stop the recording. So thank you. It's good to be